Good morning. Today we're going to be moving into talking about a section or two in chapter 1. So keep in mind when I return next week that we are going to continue reviewing the last half of chapter P so that we can have a test right before Thanksgiving break over that last half of chapter P. In the meantime, I've chosen a couple of sections out of chapter 1 that I feel like will not be too difficult and actually should be fairly simple for you guys. The first section we're going to talk about in this video is section 1.4 on linear functions and slope. So this is really just over writing equations of lines and understanding a little bit about slope. So let's just review some things about slope. Sometimes we refer to slope as rise over run. It's also represented sometimes as the change in y divided by the change in x. And in even different notation that means change in y over change in x that you might see sometimes is delta y over delta x. Okay? The delta stands for change, basically, in mathematics. So you should know already that the formula that we use to find the slope between 2 points looks like this. M equals y2 minus y1 over x2 minus x1. Let's look at just a very quick example of that. If I'm trying to find the slope between the points negative 3, 4 and the point 2, negative 2, for whatever reason that people still seem to have trouble sometimes finding the slope of a line with these 2 points because they subtract things in the wrong order or they get mixed up with the negatives. So I would just, again, encourage you, as I do every day, to write out the steps, show your work, so that there's no mistake about what's going on. And it doesn't really matter which one you want to call x2, y2, and which point you want to call x1, y1, so long as you're consistent, all right? So in this case, I might consider saying I'm going to do 4, which is y2, I'm going to call this y2, minus y1, which is negative 2, over negative 3, x2, minus x1, which is positive 2. So it would look like this. But we know that subtracting a negative is the same thing as adding a positive. So 4 minus negative 2 is 6. And negative 3 minus 2 is negative 5. And I would probably actually even rewrite that a little bit with the negative there in the middle. So we have a slope of negative 6/5. Okay. Let's talk about some different types of slope. We're going to look at just 4 different ones. We can have a line with positive slope, which would be in this general direction. We can have a line with negative slope, which would be in this general direction. We can have a line with 0 slope, which looks like this, a horizontal line. And we can also have a line with undefined slope, which is vertical. You will know that you have a 0 slope if you're using the slope formula if you end up with a 0 on the top and a different number on the bottom. You will know that you have undefined slope or a vertical line if you end up with 0 on the bottom of the slope formula. Okay. All right. I'm going to erase this. At any time that you need to pause and write stuff down, feel free to do that, or rewind so that you can actually get stuff written down. That's fine. The next thing we're going to do is talk a little bit about equations of lines. There are several forms of the equations of lines, so let's talk about those. The first form I'm going to talk about is point slope. Okay, and it looks like this: y minus y1 equals m times x minus x1. And this is used for writing the equation of a line going through point x1, y1 with slope m. Okay, so that's when we use point slope. We have another one that you're probably very familiar with, which is slope intercept. Y equals mx plus b. Okay. So this is a line going through point 0b. So in the case of a point that is 0 for the x-coordinate and some number b for the y-coordinate, that's a y-intercept with slope m. Okay. This is also what we might call a linear function, because I can also write this f of x equals mx plus b. Okay. All right, the last one that we're going to talk about today is general form. Oops. Which is ax plus by plus c equals 0, where a and b are both not 0. Okay, so if either a or b is 0, then we cannot have an equation that is in general form. And we'll talk a little bit more about why we might use general form a little bit later. Okay. Now, the interesting thing about these different equations for lines is that there are multiple point slope equations for each line. There are multiple general form equations for each line. However, there is only one slope intercept equation for each line. So it is something that is distinct. And in fact, a lot of times we're going to end up wanting to write our answer in slope intercept form because it is distinct. However, in order to get to slope intercept form, we really normally will start with point slope, because rarely will we be given information like an intercept and a slope to be able to write an equation. Most of the time we're going to be able to use point slope and then convert that into slope intercept. So let's look at a couple of examples of writing equations of lines using these different equations. Okay. So here's the first example. We're going to write the equation of the line. Through the point -1, 3 with a slope of 4. Now, the nice thing is, when we think about the information that we've been given a point on the line, and we've been given the slope of the line, so it makes sense that we would write a point slope equation. Isn't it cool how they named that point slope? Knowing exactly what you need to write the equation. So we'll just jump right in with that one. Y minus the y value of the ordered pair, which is 3, is equal to m, which is the slope, so 4, times x minus the x value of the point, which is -1. And again, we all know that subtracting a negative is the same thing as adding a positive. So we have y minus 3. This is the slope, or sorry, this is the point slope equation. Okay. However, we do want to write it in slope intercept form. So what I need to do is start by distributing. So 4x plus 4. And then I need to get y by itself, so I'll add 3 to both sides. So we get y equals 4x plus 7, and this is our slope-intercept form. Okay, so now we're finished with that problem. And I need to erase and do another one. Next, we're going to write the equation of the line through -2, -1, and -1, -6. Okay. Now, again, in order to write the equation of a line, really either one, either slope-intercept or point slope, notice that we need to know the slope. I don't know the slope yet, but since I have 2 points, I can actually use the slope formula to find it. So I'm going to say I need the slope. So m equals, again, doesn't matter which order you subtract as long as you're consistent on the top and the bottom. So I'm just going to go with -1 minus -6 over -2 minus -1. Well, that's really -1 plus 6 over -2 plus 1, or 5 over -1, which is simply -5. Okay. Now that we have the slope, we can write a point slope equation, but I'm not going to need to use both points. I only need one point out of the two to write a point slope equation, and it does not matter which one you use. This is why there are multiple, or really infinite, point slope equations for every line, because I could use any point I want off of that line to write a point slope. However, when we change it into slope-intercept, that will always be unique. So I'm going to use the point -2, -1 to write my equation. So I'll start with point slope. This is going to be point slope. Y plus 1, y minus -1, right, equals -5 times x minus -2, which is the same as x plus 2. So then we will distribute to get -5x minus 10 and subtract 1 on both sides so that we get an equation -5x minus 11. And this is our slope-intercept equation that is unique to this line. Okay. All right, one of the things that you're going to be doing a little bit of on your assignment is graphing some equations, but mostly you're going to be graphing from slope-intercept form. I'm not going to really spend a lot of time going over that because I feel like that's beating a dead horse. You've done that 1,000 times, probably between Algebra 1 and Algebra 2. So you should already know that, but keep in mind you'll always start with your y-intercept. In this case, it's -11. You will find it and graph it on the y-axis. Then you will use the slope of -5. And keeping in mind that this is like -5 over 1. So you're going to go down 5 over 1, make another point, connect the points with a straight edge, and you'll have your line. Okay? That's all I'm going to say about graphing, but you will have some problems like that on your assignment today. Okay? All right, we have just 2 more types of lines that we need to talk about. One is a horizontal line. We saw a horizontal line earlier when we were looking at the types of slope that we can have. So remember that horizontal lines have a slope of 0. So if we think about that, if we were trying to write a slope-intercept equation with a slope of 0, I would have y equals 0x plus b, but 0 times x is just 0, or we end up with y equals b, where b is the y-intercept. Okay, so this is the way we will write the equation of a horizontal line. Y equals whatever the number is that is the y-intercept. And it kind of makes sense that it's only going to involve a y, because when we think about what a horizontal line looks like, for instance, if I have the equation y equals 3, which is going to look like this, then I know that I could look at every ordered pair on this line. It doesn't matter what x is. X can be any number. X could be 5, x could be -2, x could be 752, x could be 5.29874, and the y value is always going to be 3. So when we say that y equals b, we're saying it doesn't matter what x is, the y value of the ordered pair is always going to be 3. And that's how we get a horizontal line. Okay, so in a similar way, we have to talk about vertical lines. Oops. Okay, vertical lines have a slope that is undefined. And we can't really put undefined into an equation of any sort. So we're going to look at what a vertical line looks like. And I'm just going to choose one here. And we're going to think about all of the ordered pairs on this vertical line. In the same way, when we looked at the horizontal line, they all had something in common. All of the points on a vertical line also have something in common. And the thing that they have in common is that their x values are all the same. This is the point 2, 1. This is the point 2, 3. This is the point maybe 2, 5. This is maybe the point 2, negative 5.783. Okay? So their x values are all the same. So on a horizontal line, all the y values were the same. We had y equals some number. With a vertical line, all the x values are going to be the same. So the equation is x equals a. And we just use the letter a to represent any number. Okay. All right, one last thing that we need to talk about in this lesson so that you'll be prepared to do your homework or your assignment. You need to start working on it in class, obviously. Are intercepts. Intercepts are places where lines cross the axes. So we have x-intercepts and we also have y-intercepts. Again, this is something you've seen a bunch, so we're not going to spend a lot of time on it. But to find y-intercepts, we let x equal 0 and solve for y. To find x-intercepts, we let y equal 0 and solve for x. Now, why do we need to know this? Well, we need to know this because if we have an equation of a line that is written in that general form that we talked about earlier, and we're trying to graph it, the easiest and the fastest way to graph it is going to be to find these intercepts. Also, later on in mathematics, and especially we will talk about this a lot more later on when we talk about functions more, and also when you get to calculus, we talk about intercepts quite a bit. They give us a lot of different information mathematically, and so it's good to know how to find intercepts in general, not just of lines. So this method works if you're finding an intercept of any function. All right, so let's look at an example. Graph using intercepts. And the equation is 4x minus 3y minus 6 equals 0. So you can see that this equation is in general form. And a lot of times I'll just maybe write a couple little problems here. I'll put x-intercept so I know exactly what I'm finding here. So I'm going to let y equal 0. So I'm going to have 4x minus 3 times 0 minus 6 equals 0. Or 3 times 0, which is just 0, so that's gone. 4x minus 6 equals 0. When we solve that for x, 4x equals 6. 6 divided by 4, which would reduce to 3/2. So we have an x-intercept of 3/2. Okay. Okay, sorry, the computer turned off. I needed to log back on. And to find the y-intercept, we let x equal 0. So 4 times 0 minus 3y minus 6 equals 0. Be very careful here because while this is going to go away and be 0, that's still going to remain negative. So we have negative 3y minus 6 equals 0. When we solve, negative 3y equals 6. When we divide by negative 3, we end up with a y-intercept of negative 2. Okay. The way that we graph with those intercepts looks like this. 1, 2, 3, 4. We're going to find on the x-axis 3/2, which is 1.5. So we're going to put a point on the x-axis at 1.5. We're going to find on the y-axis negative 2, which is right here. When you are doing this on your paper, it'll be very easy for you to find a straight edge. It's a little bit harder for me to do that on this board. So I'm just going to wing it this time. And we would connect those 2 points. And then we have graphed from general form of an equation of a line. All right, your assignment for this is on page 188 and 189. You're going to do 2 through 80 even. So you're going to be writing lots of equations of lines in addition to doing some graphing. If you would like graph paper, there is some in the tray over by the cabinets in my room. I have made some copies there, so you can grab some graph paper if you want. Otherwise, feel free to freehand draw some graphs like this on your paper. That's fine with me as well. Okay, good luck. Have a great day.